Hello everyone, welcome to Google AI Huddle. Thank you so much for being here, and thank you to everyone who volunteered earlier to rearrange all the chairs. We had a different setup which wouldn't have worked out, so everyone who did that, really appreciate that. Thanks a lot. How many of you are here for the first time? Okay, roughly half of the crowd. Basically, Google AI Huddle is an open, collaborative, and developer-first AI forum. And our goal is, it's driven by Google AI expertise, and our goal is to have AI conversations out in the open, right? No strings attached. You can come in, have pizza, and have the AI conversations, talk through your problems, and discuss things which you are blocked on, how GCP can help you with your AI workload, and sort of enable AI in your business and whatnot. Additionally, we also have what we're calling AI Huddle office hours. And office hours are a way for, it's still in pilot, but it's a way for you to literally hop on a Hangout VC conversation and talk to a Googler, right? So I think that's a great thing. And again, no strings attached. It's all is free of cost. And our goal really is to learn as much as we can from you, to really understand what your pain points are, and how AI can enable you and how we can enable you. With that, I'll hand it over to Shantanu.
Hey all, I'm Shantanu. I lead the Cloud AI user research team and also responsible for data analytics and IoT. So one of the missions that we are on in the user research team, so basically what we do is we bring insights from the field back to the product teams. And so this channel is a great source for us because you guys, you can connect with us, tell us about your problems. So basically, we'll get into details about your problems through office hours, through forums like this. And also we have like an hour or so before and after this session for you to network with us. So my goal personally, selfish goal here is to gather all the pain points that you have. Hopefully we can turn those pain points into product features and eventually solve your problems. So that's how I'm involved in this effort. How many of you use notebooks? I'm curious. Okay, great, awesome, fantastic. So Slava, who I work closely with, is going to be covering notebooks today, specifically with GCP in mind. Oh, okay, you want me to do the intro? Okay. Okay. All right, so.
If you want,
okay.
I can.
Okay, you want to introduce yourself? Okay.
Oh, this is okay. Yeah, I can talk about myself.
Okay, so I'll do this quickly. So Slava is a Google Cloud AI tech lead with 7+ years of experience working on deep learning images for Google Cloud AI, teaching Java courses, blogging about deep learning and TensorFlow, basically making things work. He also has a link on the Meetup event page, so feel free to check out his link and about his work. More than anything, he's just a great guy. So we partner with him and folks on his team, and we solve a lot of interesting problems every day. Over to you.
Thank you. Oh, I will probably use this one. So hello everyone. Yeah, my short name is Slava. That is my full name over there. Yeah, and before we begin, there was already several questions asked, but I still would like to ask several more just to understand what you guys are using day-to-day basis. So you already guys answered about notebook. Now the question, who is using Google Cloud? Okay, some part of the audience. Who have heard about our product, either Data Lab or Deep Learning VMs? Okay, one hand, on the one hand. Okay, but someone. Okay, Now, this talk is about, I'm going to just discuss with the main audience while you guys have time to open Twitter and just follow me with that particular tag. But while you guys doing this, I'm going to discuss who the audience for this talk. So the main audience is people who are using Jupyter Lab on day-to-day basis with a big in the team, not just by yourself as one team member per team. If you're using Jupyter Notebook for a small project that you're working on your own as a scratchbook, probably this practice is not going to resonate with you. But if you have tried to use Notebook with your bigger team with any virtual control system, you probably know how painful it is. So we're going to start the talk with Jupyter Notebook Development Manifesto. Manifesto is basically a collection of small theoretical rules or some suggestions that you guys can use. But the thing is, the key part here, that this is just a statement. There is no easy recipe how to convert this statement to a nice best practice that you can apply. In this talk, I'm going to show some of them, some recipes that you can come home and actually try to apply with your team. But the key here that this is more a concept, something that you need to try to aim, and several ideas how you can do some of the things already today. There is no silver bullet exists right now on the market. Different players trying to tackle the solution for nice collaborative notebooks in their ways. And we're going to see how Google actually solving this problem. This talk effectively featuring one article that was published with effectively this manifesto and GitHub repository. GitHub repository is the source that not only has manifesto but also has some tools that already been developed that can help to enforce some of the ideas behind the manifesto. So let's first walk step by step with each of the statement, and then we can jump to actual implementation. So statement number one, Jupyter Notebook is effectively just a tool. And as any tool, you as a software engineer do need to use all the best practices that applies to software development process. This is a simple statement, but it's actually been ignored on the in the wild drastically. And we will try to figure out why today. Second one, Jupyter Notebook needs a version control system integration. It's not, so right now if you've tried to put your notebook on the Git, you know probably how horrible this is. How horrible to do code reviews for Jupyter Notebooks, how horrible to do merge conflicts. It just does not work. The third one, Jupyter Notebooks should be absolutely 100% self-contained. We will see why and what this can give us. There should be a way to pass input arguments to the Jupyter Notebooks. And this is actually give us a powerful way to create things from the item number 5. Each Jupyter Notebook should be checked by continuous system integration. And the last one, before we're going to dive. Each notebook effectively should be plugged into a continuous development system. And each artifact produced by the notebook, if it's passing particular minimum goal of your team or your product, should be deployed as a production. The same as you will do with any other software. Now, all this effectively exists on the GitHub. You can go and check the tools that already exist. You can actually try to propose some changes if you see a typo or whatever you want. Now, in this talk, we're going to cover the first 3 items more or less in depth. We somewhat will cover item number 4 and number 5, and unfortunately it's completely out of scope number 6 as of today's conversation. There is actually P0, right? Priority 0 that is not there formally, but it should be. There should be a way for easy way to use Jupyter Notebook. This is probably the first that we're going to cover, and then we'll jump to first 1, 2, and 3. So if you're on the Google Cloud, I'm going to walk you through the solution that we have and how we're tackling this particular problem, how to make use of the Jupyter Lab very simple for our customers. How many of you guys have heard about Google Colab? Okay, slightly more than about deep learning VM. That is not a surprising news for me. but as a TL of deep learning VMs, not a happy news as well. Okay, so let me speak about these two solutions and how they're different. We effectively already have Colab, which is really simple way to start using notebooks. And if you haven't seen Colab, let me try really quick just to open a Colab. Ooh, I don't see my address. Okay, never mind. I've tried. So let me compare these two tools, and if you've never seen Colab before, just I would encourage you to go and try and search, just Google Colab, Collaboratory Google. So what are the difference effectively between these two tools? Now, let's first speak about the Collaboratory. The nice part about Colab is fast to start. You're effectively getting absolutely 100% managed environment that can be started within a second. You're just opening a browser, you can start using your notebook. You're getting for free 1 GPU, which is nice. You have K80. You're getting for free 1 TPU. Yes, it's not the latest TPU, but still it's free and it's a CPU. You now have amazing collaboration experience where several people can edit the same notebook kind of in the way how you envision the Google Documents work. Now this is a pros. Obviously, as any product, there are some cons. A Collaboratory doesn't give you any persistency. So if you're working with a notebook, your VM going to be recycled each 12 hours or some amount of hours. This effectively means that if you install your customer packages, it's going away. You're also not able to start any long-term training because your VM going to be recycled. It's not possible to use more resources. Whatever we're giving to you, that's it. You cannot attach 96 Skylake cores or 2 GPUs or 8 GPUs or whatever. There is no versioning support, which means you cannot say I need TensorFlow 110 or I don't know PyTorch 0.4. There is no integration with version control system and no nice integration with GCP. And last but not the least, there are right now in the production support 2 main frameworks, TensorFlow and PyTorch. And effectively, that is it. Now, if all these cons acceptable for you, let's say you are one-person team that develops and using notebook as a scratchpad, you probably do need to stick to Colab. I would highly recommend that indeed, if the Colab is a tool that you can use, you should be using it. Now, the second product that we have is effectively several products built around deep learning VM, which is vanilla Jupyter Lab on the Google Cloud. Pros of this stuff persistency. You're getting exactly what you're paying for. If you're creating a VM, it will save whatever you have there. If you're installing packages, it's not going to be recycled. Everything is there. It has integration with Git, flexibility of the resources. We will see how you can easily edit it, attach GPU, deattach GPU, do whatever you want. It has nice GCP integration, and finally versioning. You can specify which particular version of TensorFlow you need. Now, the cons. It's not free. You need to pay. Like we cannot give you 8 V100 GPU for free, even for a short period of time. Now, collaboration feature is not supported. That is also something that Jupyter Lab as a community trying to solve, but it's not there. And finally, time to start is slightly higher because you actually need to start VM. Now, among these products, we're going to focus on the Jupyter Lab, mostly because it's way simpler to integrate different best practices to this particular solution. And before we're jumping to different other items from Manifesto, let me show how quickly and simple it's actually to create one of the VM, because all other examples will be on the VMs. So this is how creation process looks like. Let me play a quick video. This is effectively Cloud Marketplace, let me open Cloud Marketplace, one of our products on Google Cloud. If you type there deep learning VM, you will find this solution on the marketplace. And speaking of the VM is simple. You're clicking launch, then you effectively specifying all the configuration that you want. Configuration, the name, just put something meaningful for you, something that you will know why you created this VM. One VM is effectively, you can think about one VM is one Jupyter Lab instance that allow you to run many, many different notebooks. Okay, this would be PyTorch Playground. You can specify zone. It should be obviously as close to you as possible. and the machine type with the amount of CPUs. On top of this, you can specify how many and what type of GPUs you can use. Let's pick P100. And the framework. I will pause here just for a moment. So these are the framework that we're supporting. TensorFlow, several edition. TensorFlow 2.0 is just experimental mode. Inside, we already pre-baked several interesting deep learning courses that been built around TensorFlow 2.0. Actually, I was surprised that there are actual deep learning courses already around TensorFlow 2.0. We do have PyTorch with FastAI, with FastAI course pre-built. We're actually supporting students of FastAI. We have Chainer, XGBoost, MXNet, and 4 base images. Base images is effectively just an images that has everything you might need to start using GPU. If you have, I don't know, OpenCV compiled in the way that capable utilizing GPU, and you want to run it somewhere, you need NVIDIA driver, you need CUDA, you need cuDNN, or maybe cuBLAS or something else. There is not much reason not to use base image if you're planning to use GPU, just because you will have to install everything that there yourself. Okay, so let's pick something in this particular example, PyTorch. Now, this is a feature that we just have announced. Effectively, because of the VM, as soon as you create a VM, you need to be able to access it, to run to see your Jupyter Lab. This beta feature effectively will give you a link, nice link that you can open in browser. That link would check your identity, whether you have access to this particular Jupyter Lab or not. And if you do, it will proxy all the traffic to actual VM that you have created. It's just a nice touch that allows you to access VM after the creation in a really easy way. And obviously, you need to install NVIDIA driver. Okay, so this is effectively more or less the creation part. Then you need to wait. And this is the reason why it's video, because I make it, I think, 20x speed for this creation, because it's slow, unfortunately. Yes, it would be really slow to show it in real time. In the end of the creation, you will get one particular command, executing which will give you a link. As soon as you have this link, you no longer need to do anything. You can just add it to favorites or whatever. So here is a link. And just to showcase that we do have running Jupyter, I'm going to open this link. This is your Jupyter. So that is it. You have fully worked Jupyter on the cloud with P100 GPU under the hood. There is some tutorials already pre-baked. In this particular case, this is PyTorch, so there is a FastAI. And just to make sure that GPU is actually accessible, NVIDIA CMI to show that we have P100, so everything works as expected. NVIDIA driver there. Okay, so this is simplicity. This is how you actually can, I'm going to run the whole notebook, how you can actually access Jupyter Notebook on the GCP. So we have covered this part, priority 0. Let's speak about the tooling. The item number 1 will be more conversational, and the rest of the item will be more practical. So, just the tool, what does it mean? Let's say you're speaking with Android developer, and you're asking Android developer who came to you on the interview, who wants a position in a team. You're asking, what are the best software engineering practice, like CI and CD or something like this, that you have used on your project? And suddenly the person tells you, oh, no, that is different. Like, we Android developers, we don't using all this. Like, what are you going to tell to such person? Probably, okay, it's a nice answer, we'll call you, bye-bye. But suddenly, this strange conversation somehow makes sense for Jupyter Lab. Everyone whom you're asking about Jupyter Notebook will tell you, no, we're not using it. Like, we're not using CI, we're not using CD, we don't have tests around our notebook, we don't have anything, right? Because we are different. In reality, this is just a tool. There are some practices that are specific for Android Lab or for Android Studio, that is for sure, because it's XML, because it's UI. But similar, there are some best practices for Jupyter Lab. That doesn't mean that if they have custom practices, you cannot apply generic software developer practices. Any Android app should have CI/CD with tests. Any Jupyter Lab that you're committing to the source code system should also have this. Now, unfortunately, there is no best practices tooling around on the market. That is why a lot of the people are forced to use Jupyter Lab or Jupyter Notebooks at a scratch pad. I've hearing this again and again from many developers. When they prototyping, they having a notebook, they prototyping in a notebook, but then because notebook as a tool is not ready for productional use, they rewriting the code. Usually when you're speaking, when you're diving deeper to the problem, you will see that no one wants to rewrite the code from notebook to actual Python because it consumes a lot of time, and it's actually something that you don't need to do. You have to do because you don't have tooling around. Now, there are some cases when you're actually just using Jupyter Notebook as a scratchpad. That is for sure. The same how I, for instance, have many pets projects on Android and a lot of Python on my local laptop that I not covering with CI, not covering with tooling. For that particular cases, you can use Colab. Colab is perfect solution for that use cases. If you don't need anything except one notebook with Google Drive for just experimenting, probably also don't need too much resources under the hood, Colab is ideal tool. So this is the idea on the high level behind the behind the mentality that this is just a tool. Now the second part. Effectively, all of the part, if you look on this is just extensions of the item number one. Second part is version control system. Usually when we're saying nowadays version control system, we're speaking about Git. Not many people using Mercurial, and I hope almost no one using SVN nowadays or before. So let me show you exact problem and what the solution might be for this particular element. So let me start with the problem. Here is a notebook. Notebook on deep learning VM. Notebook inside of the Git. I'm going to execute 2 cells. And from my perspective, I have not added this notebook. It's perfectly fine right now. I have not changed anything. But the notebook by itself is a JSON file that has some metadata inside. Under the hood, a lot of stuff have changed. For instance, you now have this number 1, you now have star on the second cell, then you will have number 2 on the second cell. And if you're actually going to go in Git client, we do have some Git client integration, you will see that this file has been modified already. Okay, let's assume you're coming back to this file after a week, after a vacation. You see that this file being modified, you want to see if you need to check it, to commit this file, right? You see that it's somehow been modified, and normal reaction to go and see a diff. Let me see a diff, what have I done with that particular file, what have I changed, do I need to commit it, or maybe not. It says that file that is modified. Okay, now let's see what's diff is showing us. And here is the diff. From my perspective, I actually have not changed anything in the notebook. But from the perspective of the notebook, there are a lot of stuff that have changed. And if you know how internally everything works, maybe you can guess, but maybe not. And this is just a small change. If I would execute several more cells, you will have a bigger and more horrible diff lying around. Okay, so how this can be improved? Inside of the GitHub repository that I showed in the beginning when I mentioned that Manifesto actually have some of the tools, we already have some preset of the tools that help to improve deep learning VM experience. It's going to work only on deep learning. Maybe someone want to improve it and adopt some other environments, but as of now it works only our deep learning VMs. So effectively a small script. I cloned the GitHub repository that comes with this talk. You will have the link with the slides. I'm going to run just a small script, that enables Git integration. Again, it's now has 10x speed because it will take time to integrate everything in deep learning VM that we need. As soon as it's done, it's going to reboot Jupyter Lab. This is okay. Now, let's see what have happened. In the end, now we're opening this same notebook. And what have changed is 2 small icons. These 2 small icons on top, one with small Git icon and clock-like icon. Effectively, it's one of the plugins that allow you to do really nice and amazing things. It allows you to do a normal diff of the notebooks. Here is a normal diff, which effectively shows on the left-hand side of the same cell that in was empty, now in is 1, then the second cell the same, in is 2. Nothing have changed. It has this blue item showing the diff of the metadata, but that's it. It's actually normal diff. We do have also integration of even merging and conflict resolution for the different notebooks. One more example of the diff with more complex situation can look like this. So this is just a diffing of the notebook. Again, on top of Git, it's just a normal diffing tool executed on deep learning VM that shows you normal diff. Okay, so this is how we can enforce one of the item from best practices. This is, again, just link for the GitHub with manifesto and tools. Now, third item. Jupyter Notebook should be self-contained. And first, let me show what possible to do if your notebook is self-contained. So let's say, let's start as usually with example. Let's say you prototyping your notebook. Suddenly you have decided to deattach GPU because you don't want to pay money for GPU, so you want to deattach it. Right now it looks like this. You're going to VM instances. All your instances are there, and there are probably many of them. I pick one of the chunk with a lot of instances. Now, in order to find it, you probably need to go back to your deployment to figure out the name of your instance, PyTorch 1 Playground, find it here. You're already spending some time. Now you can edit instance, but in order to edit instance, you need to stop it. Stopping takes time. Again, I have 10x rewind here. After full stop, you finally can edit it. You can edit, then you need to find where is the GPU. For me, it always takes time to find where exactly in the edit these GPU are. After the editing, I will scroll this because it's not too fun. You can actually start it again after the editing, and the start process actually takes also some time. I have 10x here for starting because it's also take time. And after you restart it, you have your Jupyter. So this video by itself is 1.5 minutes. In reality, I actually timed it, and I have it on the next slide. In reality, it takes 4 minutes, approximately 4 minutes to stop, edit, start. Now, let's say you attach GPU, you're executing your training, finally you see a bug. You see a bug, you need to debug this bug. While you're debugging, you don't want to pay for your GPU. So you need to deattach, you need to prototype, you need to attach back and start the training. So effectively, one bug requires 2 more edits, which is plus 8 minutes. So you can see it's actually a waste of time, especially if you have different bugs you need to iterate. I mean, it's good if the company pays for your resources, so you don't care, you can just attach a GPU and forget about it. But if you're actually paying from your pocket, this might be a nightmare. Now, what would be really nice to have, let's assume that you're prototyping on your deep learning VM, that is laptop with a user behind this laptop. I don't know, let's call him Bob. So the Bob prototyping on this laptop using deep learning VM under the hood, and it would be nice when needed, when you actually want to train, to spin up another instance like deep learning VM that actually has GPUs, that small tiny icons that looks like exactly like a VM icon. So it's official icon of GPU. And it looks exactly the same as icon for the VM itself, but trust me, it's a GPU. Okay, so now you want to spin up a GPU machine, execute the training there, and then give a result back and destroy that backend machine. That was really nice. You're paying only for training. But in order to do so, because that second entity, even if it's deep learning VM, it doesn't have any knowledge about your environment. Your environment that you have used for prototyping might be completely different. You might have done something strange there. In order for this schema to work, you need the notebook that actually self-contained. And even better, if you have a self-contained notebook, it might work through the source repository system like Git. You can push it, and then deep learning VM can pull it, build it, test it, and destroy itself. Let me actually show how it works already. Again, you can find the tooling for this on the same repo. So let's say I have some notebook. I'm going to actually download notebook with our Git integration from just GitHub, just a random TensorFlow notebooks. I spent some time trying to find here a MNIST example. Let me scroll this because I wasn't sure which folder it is. Yeah, so here is a MNIST notebook that I finally have found, and I want to take this and I want to train this with GPU. My local machine is CPU, and I want to send it on the background training while I can continue a prototype. In order to do so, I'm going to install the second script from the same repository. It's, again, we'll do a special magic. Yeah, we're going to the same repo that we showed before. Going to clone it. Going to clone it, going to folder responsible for self-contained notebooks. And there is a script enable notebook submission. Again, as of now, it's working only with deep learning VM, not on all the Jupyter instances, but this is, yeah, this can be changed. Now let's go to the folder that contains my notebook that I actually want to execute. I know the folder, I just copy it. And if everything is done right, you now have 2 CLI commands that are available to your usage. Let me show you that the commands. Yeah, these are the 2 commands. Execute notebooks with CPU or with GPU. There are 4 input arguments to this command. One is name of your notebook. Another one is Google Cloud Storage temporary bucket. And for CPU, that is all. That is all you need to provide. For GPU command, you also need to specify type of GPU and amount of GPU. In my case, as I said, I want to train this notebook in the background with GPU. So I'm using execute notebook with GPU. Then, as I just mentioned, I'm providing name of the notebook. Then I have some pre-populated Google Cloud storage. You need to be sure that your VM has access to that storage. This is storage v101. So I do want to train with one v100. That is effectively it. What is happening right now, it's uploading everything to GCS, starting VM, starting the training. This is, again, fast reboot. Each 10 seconds I show you. There is a small error in there that just because script as of today, just checking if this background VM actually exists. And the error means that it no longer exists. It means that trainings have succeeded and the VM has self-terminate itself. And the result being uploaded to GCS. As of today, result notebook has name, surprise, surprise, notebook.ipynb. It's always notebook ipynb. And this is a notebook. You can see on the left panel that it's created a second ago because it was downloaded from our background VM, and it's fully populated. So all the cells are there. It's actually have executed everything, and this is effectively one of the recognition. And the training actually happened on v100 on the background. So you're going to pay only for time of v100 that you have used for training. If something has crashed, you will see crash here. You can restart your notebook here with CPU. You can prototype again. When you're ready, you can go to your console. You can submit your notebook to the background training. But, as I said, it should be self-contained. Okay, so we have discussed this, and just to show on the diagram what has happened, we have one VM. We effectively upload our notebook to cloud storage. We have spin up deep learning VM. Everything the script is doing for you. That deep learning VM has downloaded your script. Then we're using technology that has named Papermill. That was developed by Netflix. Papermill is basically a special open source tool that is in charge of executing notebooks locally without any UI interface attached. And as soon as this succeeded, we've done the hooks through cloud storage back and destroyed the backend VM. That is pretty simple. And it worked. Now, we always were saying that you need self-contained notebooks. Let's speak about what exactly this means. What self-contained means? Several things. Thing number one, you need to have notion about which deep learning VM, like TensorFlow M20, you have used for creating notebook. Our deep learning VM has already tons of different packages. Very likely, you will not need to install anything else. You can use CNTK, NumPy, Pandas, Scikit-learn, tons of them already there. But they have different versions. So you need to make sure that the notebook has information that it was created with M19, M18. In this way, we can spin up exactly the one deep learning VM that has exactly the same set of packages and the version. This is number one. Number two is simple. If you do need any dependency, please use magical cell inside of the notebook that install them. That's it. I mean, I do understand that there are some cases when it's actually not practical. There are tons of dependency, and magic cell could be huge. In this case, we do have several other ways, but in many cases you would be surprised. Deep learning VM already have majority of the things you need. You can just install two packages. I don't know, maybe you need MXNet for some reason. You can install it already. Just use magic cell. That is it. It's actually pretty simple. Now, limitations. Current limitations of this particular script. The solution itself can be extended. All these limitations can be solved, but current limitations, if you're coming home, if you're going to actually use the script with a deep learning VM, there are some of current limitations, and actually many of them. Right now, only works with TensorFlow VMs. We do have PyTorch VMs, but this is not going to work yet. Only works on CLI. I personally would be thrilled to see a nice button. You pressing the button, it magically goes there and then magically come back, but for now it's only CLI. Third one, always uses latest TensorFlow. Yes, I know I have told you like a moment ago you need to know which particular version, but for now it's ignored. It always will use TensorFlow latest, even if it was created not with the latest. For now. It's not capable of catching files around the notebook. Again, it's not a problem. You can upload your local folder to Google Cloud Storage and download it, and for the backend VM, it's just current implementation is not capable of using files and artifacts lying around. Not yet possible to pass any input arguments, and this is actually very important. But here is a link to GitHub. Please do feel free to contribute. Pick any of these and solve it if one of them actually creates more pain than other for you. Now, next two item that we will just going to cover without diving too much. It's input argument and why this is important. And this is almost last of my slides. This is example from one of previous notebooks. We actually don't care what notebooks is doing, but it has number of steps. Number of steps is something that reasonably you want to change. You might want to test with different batch sizes, different number of steps, different learning rates. It's something that you want dynamically to adjust. When I'm saying that notebook should have ability to process input, I mean that you should be able to override these variables from outside of the notebooks without changing notebook. This is powerful concept that again Papermill and Netflix has implemented already. That script that I have used doesn't have this support, but with this particular ability to override these variables, you can actually implement full continuous integration system. Imagine a notebook. But when you're sending this notebook to the Git, continuous integration system pulls this notebook, overrides variables. For example, it overrides name of the table, and instead of the production table, it's using table with mock small amount of data and executing everything with that small amount of data just to verify that the notebook is working, completely working. And if something is broken, it's pages whoever is on call or whoever is in charge of the build. All this is possible if you do integrate this capability of input arguments. So this is effectively covers the last two, why it's important to have ability to pass input argument to notebooks, and the CI. Effectively, if you're solving number 4, number 5 is technicality. This is actually all. So this is 5 elements, if we're counting 0, 6 elements. We have not covered the last one. As I said, this part yet is out of scope. Just to recap, just to mention, this is more an item that you should aim for. GitHub has script that will help you already to enforce them, but don't think about that GitHub as a productional solution that you can just use. There will be a lot of problem, but it will give you some flavor of how future of the notebooks might look like. And that is all. Thank you very much, guys. Let's move to a question QA part if there is any question. Thank you. Oh, we have a question. Can someone help with passing the mic? Yep. So, because yeah.
It could be a silly question, but can you compose notebooks? Can you include one notebook in another and then run it?
So
do you have that capability?
Okay. Yeah, just want to mention there is no like silly question. There's only silly answers. But yes. Question was if I can use one notebook in another one somehow. Yes, you can. I mean, you cannot with vanilla notebook. You do need to install several plugins or paper mill or something that allow you this capability. But there are several solutions on the market already that effectively allow you to say something. I need variable A from the notebook blah, and it will execute notebook blah until A is populated, and then we'll import A. So that is already possible. Yeah. That is actually, there are, even though technically it's solvable, it's open question about best practices, whether this is recommended way or not. My personal take on this is that if you're using generalized logic, it's better generic logic to be just a pure Python, if you want, with just imports. But technically, yes, you still can import one notebook from another. Thank you. Any other questions? Yep. Can you please pass the mic? Yeah, sorry, because with microphone, you guys will be recorded.
You should have another one there.
We do have another one.
Yeah.
Yeah.
Okay. One for each. So you were talking about tests. So you were saying that if we can input parameters, then we can just change the table name or some part of the table name, and then we can read like mock table names. And so is your vision that those the test tables will be sort of automatically generated, or you are envisioning something that you have to create the table, and then the test cases for like the rows that you want to test, you have to write it, because that's pretty painful. And if you have two tables, you just can create the mock tables, but otherwise it will be kind of hard to create tables like with all the edge cases. What's your vision about testing? Because in general, testing programs, we're used to it, but testing programs that process data, or the data logic, we are not used to it in the data industry, right? Kind of.
Yes.
So how do you envision that?
So okay, your question is actually absolutely right. If you're going to manually mock the database, it might be kind of painful. So there are two things here. First of all, for notebooks, usually the simplest way is let me first say one more thing. So you have usually most popular unit test and functional test, right? Yeah. For notebooks, it's harder to do unit tests. It's simpler to do functional tests when you're running the whole notebook. Now, in this particular example that I showed to you, just writing input variable will force you to create yourself manually a table, which is horrible. But this is just the first step. The second step, you still can have a normal Python test that will generate data, then that will call training on that data, and will check the result. I have not showcased here the actual CI, but CI that we have for a demo actually doing like this. So because it's not just deploying background training, it's first generate data, deploys background training, and checks that the artifact that notebook's submitting actually has results from that table, just to make sure that is working. What is we right now definitely missing is ability to go even deeper and do, for instance, unit tests, like particular cell that you can extract that part. No, you cannot.
But for the unit test, you will have to make it more modular, or just identify tags on modules, different parts of the
Correct. Yes.
Then you can test.
That part will be harder, but yes, it's possible. Definitely. Yes. Any other questions?
I can make another question if you want.
Sure.
So you, at the beginning of the talk, you were mentioning Data Lab?
Correct, yes.
But you didn't talk about Data Lab. I mean, you didn't show it and all that.
Oh yeah, I asked if someone knows Data Lab. So effectively, indeed, I have to show it, and one of the reasons because you can think about deep learning VM solution as Data Lab P2.
Oh, okay. So that's already there somewhere.
Deep learning VMs?
No, the data lab v2.
No, the solution deep learning is by itself a data lab v2. So with reincarnation, it's not yet a parity in the features. That's why you would not find this statement yet.
Oh, that's the question. Okay, good.
But at some point, it will have parity of the features plus other features.
Great. Thank you.
Anything else? Okay, then thank you guys. Have a nice evening.